Hi my dear student, welcome to my physics LCR class. Today I am going to explain in the matter topic only, under the matter topic, property of gases. Property of gases we are going to study. Property of gases. So today we are going to study about property of gases. Gases do not have definite shape and do not have definite volume. No definite shape, no definite volume. Which container we are keeping the gases, that gases occupying the shape of the container and volume of the container. Shape of the container, volume of the container. So gases do not have definite shape and do not have definite volume. It more compressible. Liquids are more compressible. How it is more compressible? Suppose 1 liter container you are taking. 1 liter container you are taking. In this container you can fill with the gas 1 liter or 1 kg. 1 kg. 1 kg gases you are filling. So you particular temperature you can fill with more gases. It may be 1.5 kg, it may be 2 kg, like that actually we can fill that. So that's why we can say gases are more compressible. It can flow easily. It can flow easily. Liquid can flow easily. It is least dense actually. Very less dense. Another one, molecules very loosely placed. Molecules very in gases, molecules very loosely packed. Just here I given a molecular arrangement. Just you see the molecular arrangement, how it is arranged. Gases in gases. In between the two gases, atoms, it is a space is large actually. Very much space. So that's why intermolecular space is large, intermolecular force of attraction is least. Intermolecular force of attraction is least. So here space is more, intermolecular force of attraction is least. That's why it does not getting a definite shape. The molecules arranged closely, so it is getting a particular shape. Solid has a definite shape. Okay, so here very loosely arranged atoms and molecules, very loosely arranged. That's why it does not have a definite shape. Due to its weight, suppose this container having the gases, so it is the gas actually giving the weight. So the atoms of gases, no, it is going to hit on the container or any direction it going to hit. So force will be formed. That's why pressure will be created. So it exerts pressure in all the direction. Gases, due to its weight, it exerts pressure in the all the direction. Which container we are keeping? Which container we are keeping? In that container it will produce or exerts the pressure. Very weak intermolecular force of attraction. Why it is having a very weak intermolecular force of attraction? Here just to see the molecules very closely, the attraction between two molecules, the force will be creating, it is more. So here intermolecular force of attraction is more. Here just you see in the gases, it is very apart from each other. So two molecules or two atoms, no, placed further apart from. So that's why space is large, attraction will be less. Space is large, in molecular force, intermolecular forces very weak. Intermolecular forces very weak. Next, more thermal expansion. Liquid giving more thermal expansion, very More thermal expansion it is giving. Much more expansion. In solid actually there is very little expansion. Water actually little more. Here very much more. Much more expansion is there. So when you are heating the gas, you are heating this container, the gas expands very large quantity, large scale actually it will expand. So more thermal expansion is there in gases, more thermal expansion is there. Molecules are free to move. Molecules are free to move. Okay. Suppose that is I told na very big container you are taking. 10 kg container even though you take, you put a 1 kg or 1 liter gas. That gas actually whole 10 kg container it will occupy. So it is freely moving here and there. It is freely moving here and there. 1 kg you are keeping, 1 kg gases. Suppose gas, if you are keeping a 10 kg container is very large, you are keeping in that container also 1 kg, what will happen? That gas actually occupying in the whole 10 kg container. So that's why the molecules are free to move from their position. Freely it is moving. So gas molecules freely move here and there. Do not have any phase. It is a surface we are studying. Do not have single surface. There is no surface of the gases. Why it is not having? Because actually it is free to moving. In which container we are keeping, that container shape it is occupying and it is getting that volume. Here gases do not have surface tension. Why the gases do not have surface tension? Surface tension, but liquid has surface tension. But here does not have surface tension. Why? Gases do not have surface tension property. Why? Because they don't have surface. They don't have any surface. That's why the gases do not have surface tension property. It is not rigid. It is not rigid. It easily can flow. It is easily flow. Suppose you take in the container you are taking a water, one container, nothing you are keeping. We are not keeping anything. We are not keeping anything. That container occupied by the air. Occupied by the air. Suppose you keep in this container, you are keeping a water. In this container, empty you are keeping. This container is empty. This container is empty. Empty means here air is present. Here air is present. Okay. So water also can flow, but air or gases also flow. We feel breeze. We feel wind. So here actually air actually forming some pressure. That's why it is moving. Air molecule moves. Okay, it can flow from higher pressure place to lower pressure place. Higher pressure place to lower pressure place. Wind actually blows. So that's why we can say gases flowing. Gases flowing from one place to another place. One container to another container. Easily we can transform. Last property is easily diffuse into another gas. One gas diffuse with another gas. Diffusion. Suppose we are applying a spray. We are applying a spray. When you are moving here and there, that smell actually flow. So from that spray, the gas molecule move into the air. Move into the air. So gases now diffused easily. Gases diffused easily. Aquatic animal and plants. Aquatic, you know about aquatic animal, they needs oxygen. How they are breathing, how they are taking the oxygen. Oxygen, aquatic means some pond just you consider. In the pond actually plants are there. Sorry, water is actually filled in the water body, that is a pond. Inside actually the fish is there. Fish is there. Plants are there. Plants are inside actually. They need oxygen. How they are getting the oxygen? From the outside actually oxygen molecule, it is entering here in the water. It is going to mix. It is going to mix. Okay. So oxygen actually easily dissolve in water. Oxygen easily dissolve in water. So aquatic animal and plants taking the oxygen. How they are taking the oxygen? The oxygen actually it is easily dissolved into the water. Here I am telling about gas and liquid. Gas and liquid. Gas into another gas. Gas into another gas. How you can say gas into another gas? Spray, it is a gas. Air is a gas. So spray particle move into the air. Spray particle move into the air. So that's why we can say it is easily diffuse into another gases. Easily diffuse into the another gas. So here property of gases. Gases do not have definite shape, definite volume. Gases more compressible, it can flow easily, least dense, it is light, we can say least dense means very light. Molecules are very closely, not closely, loosely packed, very loosely packed. You see the atomic structure here I given. It is very loosely packed. Due to its weight, it exerts pressure in all the direction. It is air pressure we are getting. Air pressure. Atmospheric pressure. No? Air is there. So we are getting a pressure about air. We will study in higher classes. Very weak intermolecular force of attraction. Very weak intermolecular force of attraction. The thermal expansion is more in gases. Thermal expansion is more in gases. Molecules are free to move from their position. It is moving here and there. Just you are keeping in a container that gas molecules, no, it is moving here and there. It is moving here and there. Carbon dioxide you can keep it. Oxygen cylinder, no. We are in the hospitals, we are using oxygen cylinder. Okay, in the oxygen cylinder it is filled by the oxygen. Okay, so molecules are free to move. Next, do not have any surface. Gases actually do not have any surface. It does not having a surface tension characteristic. Next, it is a not rigid. It is easily flow. It can easily flow. Easily diffuse into another gases. It is easily diffuse into another gas. Diffuse means it is dissolved. Here I told no, oxygen dissolve in water. Oxygen dissolve in water. Here I given a gases atomic structure of gas. Okay, small container, 1 kg container. It can filled with 1 kg gas. In same container you can fill it 2 or 3, 4, 5 kg gas also you can keep it here. So from that actually we can understand gases more compressible characteristic. Gases more compressible. How it is compressible? You can understand actually. Intermolecular space is large. So when you are going to compress, what will happen? It is coming closer to each other. The atoms coming to close to each other. In solid actually, solid is not compressible. 1 kg container you have to keep it 1 kg solid material only. But 1 kg container you can keep 1 kg gas, 2-3 kg gas also we can keep it. Okay. So I am going to complete this session. Please go through it. You have to study girls. Study students. I am always telling about girls because I worked past 25 years. I worked in a girls school. So that's why I am telling about the girls. So boys also study well. You should Work hard, you should put a effort. You make a revision. First to learn, then write. Write and learning is very, very important. You have to write also. Only learning is not sufficient. Only learning is not sufficient. You have to write also. You memorize 2-3 times. You have to write actually. Revision also very important. So in my LCR means what? My class I am writing LCR. So learning is a continuous process. Throughout the life you can learn it. Throughout the life you can learn with revision. That's why I given LCR. Why you people think no what physics Mrs. telling physics LCR class, physics LCR class. LCR means learning is a continuous process with revision. Repetition, we have to repeatedly do the work. Revision is there. Revision also very, very important. Okay. Thank you, student. Thank you. Bye.